Alrighty then, corn children, children of the corn, we are going to be looking at the technique of using the chain rule to find the derivative. So, first of all, what is the chain rule? The chain rule is used when we need to take the derivative of not just a function, but a function within a function, the composition of functions. All right, so here's your process. We will take the derivative of the outer function, but we will leave the inner function alone. That's the leave it alone. And then we will multiply by the derivative of the inner function. That in a nutshell is your chain rule. So let's see some examples of, first of all, when would we need it and how to make it happen. So here's our first example. How about y equals the square root 5x squared plus 2. All right, so first of all, let's be clear. We do need to use the chain rule here. This is a polynomial inside of a power. So the outer function is the power rule. The inner function is the polynomial. With this notation, the outer function f is going to be raising it to the 1/2, and g is going to be basically, I'm lumping together the polynomial. All right, so let's take the derivative. It is an equation, and we're taking the derivative of both sides. The derivative of y is dy dx, and then here we go with our chain rule. I'm going to break it down nice and slow. We are going to start with the power rule. We are not considering the inner function, we are just looking at the power rule. Power rule says that the coefficient, or the exponent comes down to become the coefficient, the exponent drops by 1, and here's your leave it. We're going to leave this alone inside. Then we will multiply by the derivative of that inner part. So we have done the outer one, we've done the f prime g of x. The g prime is the taking the derivative of the inner part. So that's pretty straightforward. Just going to bring this down. And then it is multiply. The derivative of this is, of course, 10x. The 2 times 5, exponent drops by 1. Derivative of a constant is 0. From here, it's just cleanup work. The 10 and the 2 cancel. This is a negative exponent, so we drop it like it's hot. The 5x is your numerator, and this is the square root of 5x squared plus 2. Very fancy. There is your first one with a chain rule. This next one, it's going to be a little bit trickier. We're going to do a double chain rule, chain rule. All right, so here we go. This is going to be y equals, throw some trig in here, sine to the 6th, 3x. Now the first thing we need to understand is this really truly is a double chain. This is sine, which has a 3x inside of it, all raised to the 6th power. So the 6th power is the outermost function, and then we have trig, and inside of the trig we have a change in x, 3x. All right, here we go. I'm going to be using this one, and I'm going to take the derivative. I am starting with the power rule. The 6 comes down, the exponent drops to a 5. We will leave this alone, leave it. Then we are supposed to, and we'll do it in the next step, take the derivative of the thing we left alone. So this is the first of the chain rules. So now this part's just going to come down. I am going to pop that 5 back in here in our standard notation. 6 sine 5th power 3x. And now we're focusing back here. Here we have an outer and an inner. The outer function is sine. The inner function is 3x. This is not multiplication, people. This is composition. It is a 3x inside of a sine machine. So starting with the outer, the derivative of sine is cosine. Here's where we get tripped up. That 3x, leave it. Do not change that 3x. That is the 3x left alone. And then we multiply by the derivative of what we left alone. Now, obviously, you could do that in your head. You don't need to do it in a separate step. The derivative here is just 3. So that we can see all the pieces parts, and then the derivative of that is 3. Tradition, of course, will put the coefficients all together, making this an 18. So, final answer, 18, sine to the 5th, 3x, cosine 3x. 2 examples of the chain rule. I hope you enjoy them. All right, campers, there it is.